Hello, good day everyone. Welcome to our session for today. We are going to discuss today the integration procedures. So our objectives for our lecture today are the following. At the end of the period, or shall we say at the end of the topic, you should be able to evaluate integrals using integration by parts, evaluate trigonometric integrals using appropriate procedures and trigonometric identities, use trigonometric substitution in evaluating integrals involving roots, use partial fraction expansion to evaluate integrals, and apply substitution technique in dealing with integrands involving irrational expressions. So for this video class, I'll just focus on the first objective: evaluate integrals using integration parts. So I will focus on the integration by parts. And the rest of this will be discussed in another video. Okay. So we have here what we call integration by parts. So we have a formula here, class, that we need to remember. Okay. So we have, if you're given the integral of u times dv, this is equivalent to u times v minus the integral of v du. Okay? To give you an example on how to use this formula, so we have here 5 items, but for this video, I will solve only one, and the rest will be solved in the other video. Okay, so we are given here number one, integral of ln x dx. Number two, we have the integral of arc sine of x dx, and we have the integral of number three, we have integral of x times e to the x dx, and number four is integral of x cosine 2x dx, and the last one is integral of secant to the third power, or secant cube x dx. Okay, so to solve these items, I will begin with number one, then I will separate the rest, the solution of the rest of these examples in the next videos. One of the videos, class, that I'm going to give you will involve, no, some of this number here or items will involve some integration formulas, just to give you an idea on how to solve those problems that cannot easily be solved using the technique that we have discussed before. So I want you to take note on this following class. Okay, I will expand this one. So we have here the basic trigonometric derivatives and their corresponding indefinite integrals. So some of these problems will use some of these formulas, class. So these are the additional formulas that you are going to add in your Cartolina. Okay, so for your PIT. This is what we had in our differential calculus. And for the integral calculus, these are the formulas that you need to add in your list or on your list. Okay, we have here the integral of cosine x dx equal to sine x plus c. The integral of sine x dx equal to minus cosine x plus c. So if you compare it in the differential calculus, if you have memorized this already, so at least these ones are also easy to memorize. They're very related, class. Like for example, derivative of sine x equal to cosine x, but integral of cosine x equal to positive sine x dx. But for the derivative of cosine x, which is equal to minus sine x, in integral, so this is integral of sine x dx equal to minus cosine x dx. Okay, and then if you look at this for tangent, you see they're just related, class. as mentioned, no, this is just the antiderivative, these formulas here. So I want you to take note on this. So going back to our example, so example number one, we have integral of ln x dx. So how are we going to solve this? If you recall all those concept that we had discussed, and also the examples that we have solved, so this given here, this example number one, is really very different. So if you don't know this formula, the integration by parts formula, you will not be able to solve this problem. Okay, so to show you the solutions, so here is the okay, here's the solution class. So we're given the integral of, okay, so our example number one. So we're given the integral of ln, integral of ln x dx. So we are going to solve this problem, or this integral, using the integration by parts. So the formula, no, in our integration by parts, we have integral of u times dv. This is equal to u times v, okay, u times v minus the integral of v du. So this is what we are going to refer when we solve this problem, class. So it's a matter of finding what is our u, what is our v, then after that substitute it in this formula. Okay, so if we let u, so if we let u, so what do you think is our u here? What u, or which of this? We have ln x as one, then we have dx as another part. So this is the product of ln x and dx. So we have two factors here, the ln x and also the dx. So you have to select between these two factors, which is our u and what is our dv. Okay, so if we consider this as our u, so we say let u equal to ln x. So if this is u, then the other one, the other factor, must be our dv. So our dv is equal to dx. Okay? Then after that, we have to find, no, as usual, we have to find the derivative of u with respect to x. So differentiating u with respect to x, so we have derivative of u with respect to x equal to, so this time we are going to recall, no? We have to recall our knowledge on the derivative of ln. So what is the derivative of ln? Derivative ln. So the derivative ln is equal to 1 over, we have the formula, class now. We have derivative of ln u. If you have this derivative of ln u is equal to 1 over u times the derivative of u with respect to x. Okay, so that is the general formula of the derivative of ln of u. So following this, so we can say that if this is our ln u, meaning our u is equal to x, don't be confused when you let u equal to ln x. But when you use this formula, derivative ln u, whatever is the expression after ln, so that is also our u. So ln u, but it happens that our u here is equal to x. So using this formula, so we have 1 over u. So whatever is this expression or number or um, factor, then you have to take the reciprocal of that. So 1 over that expression. So 1 over u. So in this case, we have ln x. So this is 1 over x times the derivative of our u here is x. So meaning we have to take the derivative of x with respect to x, which is equal to 1. Okay, so derivative of x with respect to x is equal to 1. So this is just equal to 1. Okay, so therefore our du over dx, or derivative of u with respect to x, is simply equal to 1 over x. Okay, so this is 1 over x. And solving for du, since we let this one as our u, so it must be du. So we have to find dx in terms of du. So we have du equal to, so multiply both sides by dx, or cross multiply dx. So we have dx over x. So this is dx over x. So you can write this as 1 over x times dx. So they're just the same class. Okay? Then we have here dv equal to dx. Now, if we are going to integrate, no, if you are going to integrate dv, okay, so derivative of v, and then you integrate that one, so what will happen? So that is the inverse process, right? So it means that if you integrate dv, so if you integrate dv, by the way, to remain this equal, meaning to balance left and right, so what you did in the left side, you have also to do that on the other side, on the right side. So you also take the integral or integrate the right side, which is dx. And we know that this is an anti-differentiation, this one. So you do the differentiation, then you do the anti-differentiation. So it's just like nothing had happened. So you have v equal to x. Okay? So the technique here, class, is something like this. You just write, I will have to rewrite it here to summarize. So I want to rewrite it here. So we let u equal to ln x. Okay, and then we obtained du, where our du is equal to dx over x. You don't have to do this, class, but for emphasis, I rewrite it. Then we had our dv which is equal to dx. Then after integrating both sides, we got v equal to x, right? So after integrating, we got v equal to x. Okay, so what you're going to do, class, when you do the integration by parts, so you summarize what is your u, what is your du, then what is your dv, what is your v. Then you just drew the vertical and horizontal line, something like this. Okay, then after that, so I find it very helpful, class, so I want you to adapt this technique, no? So when you look at the formula, integral of u times dv is equal to uv. So it means you just multiply u and v. Okay, so using this formula, by the way, I will write it here. So equal to, so this one is equal to, using the formula, u times v. So we have u. What is our u? Our u is ln x, right? Ln x. Then times v. What is our v? Our v is equal to x. So times x. So you have ln x. You multiply this by x. Okay, because this is u times v. So u is ln x. Our v is x. Then minus the integral of v. What is our v? Our v is equal to x. So you write it here, x. Then times du. What is our du? Our du is this one. Our du is equal to dx over x. So you write it here, dx over x. Okay, so equal to, since this is multiplication, class, so you can rearrange this as x times ln x. You may put this inside the parenthesis or not. Class, they're just the same. Then minus, so we have x at the numerator, you have x at the denominator. So what will happen? So you have x at the denominator, you have x at the numerator, so x divided by x is equal to 1. So what is left? So what is left now is integral of dx. Okay, so equal to x times ln x minus, what is the integral of dx? Integral of dx is simply equal to x, then plus the constant of integration c. Okay, so that is our answer. Or you can factor out x, because it's common here on these two terms. Common is x, so you can factor out x. So this becomes x times ln x, then minus 1, then plus c. Okay, so this is our answer. So you can have this as your answer, this one or this one. All right, so I hope you were able to follow, class. We'll have more example in our next video. So I will end this video up to this part. Thank you very much. Bye.